The concept of statistical significance is established in all natural sciences, but sometimes it seems that people misinterpret statistical significance. Maybe doctors may say, yeah, it's statistically significant, but clinically it is not. Or some researchers may say, I do see a clear difference between these groups, although it's not statistically significant. So what exactly does statistical significance mean? We can ask different questions when we compare groups or when we try to find out if there are effects or relationships. Is there a difference between groups? For example, are there differences due to treatment? How large is this difference? Is the difference meaningful in practice? For example, is it biologically, medically, or psychologically relevant? The first question can be rephrased as follows. Are we sure that a given difference is not present due to chance alone? When we have a sample, naturally, there will always be some variability between the groups. For example, we will never have the exact same average height in two classes of fourth graders. Naturally, there will be some difference. We want to know if a difference is really there, for example, because of a treatment, or if it is just a random difference. And this question is answered using statistical tests. We conduct a test to reveal if a difference is statistically significant. That means if a difference is there due to chance alone, or if there is more behind it. This is what statistical significance means. It doesn't say anything about the magnitude of the difference. Even a difference of only 1% can be statistically significant if you have a large enough sample. This brings us to a very important point that we always need to consider. The absence of a significant difference can mean that there is in fact no difference. However, it can also mean that your sample is just too small to detect a difference. So statistical significance is linked to sample size and also to study design. Let us continue with the next question. The magnitude of a difference tells us how big a difference is. However, a difference may just be random because of natural variability, as mentioned before. Or it may be an actual difference, maybe due to treatment of patients with a pharmaceutical. Hence, the magnitude, the size of the difference, alone does not help us very much. Only when we also know if a difference is statistically significant, can we decide how to interpret the magnitude of a difference. Now let's come to the final question. Is a significant difference meaningful? This actually depends on the context. This is shown in a paper from Bartolucci and colleagues from 2011. The authors wanted to know if aspirin can help to prevent myocardial infarction. They observed over 22,000 subjects over a period of about 5 years and found that indeed aspirin was significantly associated with myocardial infarction. As a consequence, aspirin was recommended for general prevention. However, the effect size was extremely small. The difference of the risk with or without aspirin was only 0.77%, less than a percent. Hence, participants had almost no benefit when using aspirin. From this example, we can see that the magnitude of an effect and the significance should both be considered together, in particular when decisions have to be taken that have considerable consequences. So, this was a summary regarding statistical significance and effect size. In summary, we always need to consider both the magnitude of a difference and the statistical significance. Then we can finally consider if a difference is meaningful in practice. If you liked the video or you would like to see more statistical content in the future, please like, share and subscribe.